Okay, now we're working on this graph of this function. So we immediately find the zero. Well, x minus 2 equals 0, so x equals 2. X plus 5 equals 0, so x equals -5. X minus 6 equals 0, so x equals 6. Now, the multiplicity, 3 here. Multiplicity is 1 here. And the multiplicity over here is 2. Y-intercept. X equals 0. So y equals 0 minus 2 cubed times 0 plus 5 times 0 minus 6 squared. That's going to be minus 8 times 5 times 36. And I think that's 1,440 next negative. Okay. Well, that gives us enough information to start the graph. Oh, that we're going to have a 0 at x equals -2. That's already at x equals -5. And at x equals 2. And at x equals 6. And we know the y-intercept is going to occur at y equals -1,440. Now, x equals -5 comes from the x plus 5, which is linear. Okay? So we can say this is going to be linear. That means, like, if this is the 0, it's going to go through it with a straight line. Maybe this way, or maybe this way. Okay? Because it can always, you don't know what's going to be positive or negative until you analyze it. At this point, it's going to be cubic. Means it's going to do this. And then this. Or this. Okay. Then at x equals 6, x minus 6, and it's cubic because x minus 2 is cubed. X equals 2. The 0 at x equals 2 comes from x minus 2 equals 0, but x minus 2 is cubed. So it's going to act like a cubic graph here. Then here, the 0 at x equals 6 comes from x minus 6 squared. So this is going to be squared. So that means it'll either be like this. Like this. I mean, it'll be too sharp, but the track just won't behave. Okay, I do rule my hand. Okay, so we know that here it's going to go right through. Here it's going to level off and come back up. And here it's going to come down and act like a square. And of course, it's going to go through the y-intercept. Let's check the long run behavior, the end behavior. as x goes to infinity, all three of these are all large and positive. So y goes to positive infinity. X goes to negative infinity. Factors are large and negative. There are 6 factors. Okay. Get that onto the screen. Okay. So as x goes to negative infinity, x minus 2 is negative, x plus 5 is negative, x minus 6 is negative. Just imagine x is negative 1,000,000. Okay. Then that's going to be real close to negative 1,000,000, and that's going to be close to negative 1,000,000. That's going to be close to negative 1,000,000. Now, of course, then that's going to get cubed and that's going to get squared. So we have 6 factors and they're all negative. Okay. The product of 6 negatives is positive. So plus infinity. That's your reasoning. They should write out all of that every time you do one of these, so that when you get to the test, you're going to know, and you're going to write it out on the test, and you're going to do real well. Okay? But you got to practice. You got to write it out, because writing it out forces you to focus on the details. Okay? So having done all that, we know that, well, okay, then as x goes to infinity, y goes to infinity. As x goes to negative infinity, y is going to go to infinity. And x doesn't have to be far from the rightmost zero before it starts going up really fast. And it doesn't have to be far from the leftmost zero before it starts going up real fast. You don't have to go out to 1,000,000. Okay, you go out to even 10 and you're going to start getting big numbers. Yeah, think about it. If x is 10, you got 8 cubed, you got 15, and you got 4 squared. That's going to be 64 times 15 times 4, which is 256, 560, close to 4,000. Okay. So you just go out from here to here and you're going to be up 4,000. Of course, on the scale here, y is negative 1,440 here, so 4,000 would only be up about here, but that's about right. Okay, well, you don't need to understand that, but now we have to start from up. We got to go through this in a linear fashion. So we come through here. Do tend to get that curvatures in here. That was just an accident, but chalk. come down like so. We're gonna go down, some point it's gonna turn around and start coming back up. Okay? It's probably not gonna turn around here. This doesn't have much room to get from here to here. So it uses up some of the room you have between here and here. You go down to some minimum, but then it's gonna curve back up. Then it's gonna act like a cubic function. Okay? So it's gonna look like it pretty much just joins up with the x-axis here for short. And this one's gonna kind of be right in the middle of the part where this thing looks like it's on the x-axis, even though it really isn't. So close you can't tell the difference. Then it's gonna come on up. It's not gonna come up very far because it's got to turn around and hit this thing. And when it hits this thing, is it going to go straight through? Well, no, because it's going to be this way or this way. Well, since it's going to be above, it's going to be like this. Okay. Actually, that's a pretty good graph, except that kind of stuff. So it's always got to be okay. Make sense? And that's the process. Okay. So again, I recommend you write that out. Okay. Okay. Now, two different one. Let's say we've got okay, let's see. To make it easy. We know this is by trial and error. Okay. We try small numbers, 1, 2, 3, -1, -2, -3. Okay. If x is 1, we get 1, and we get 2, and we get -4, and we get 1, right? Well, 1 and 2 is 3. Subtract 4, you get -1, add 1, you get 0. So, bingo, we hit the jackpot right away. So, okay, you plug in 1, you're going to get 0. So, x minus 1 divides p of x. Without remainder. By long division. So we're going to divide x minus 1 into x cubed plus 2x squared minus 4x plus 1. So go ahead and do that. See what you get. So So we're wanting to divide this into this. We've figured out that this polynomial has a 0 when x equals 1. Okay, we just kind of looked into that. Just by testing, plugging in 1, we found that it works. So that this should divide this without remainder. Now, first thing we do is we put x squared here, because we multiply x squared by x, we're going to get x cubed. So we have to have an x squared in the quotient, so that we multiply the quotient by the divisor, we get the dividend. Okay, we get our polynomial. Okay, so we get x cubed here. And of course, we have an x squared up here. And this is part of our quotient. It's going to be multiplied by the -1, so we better put a minus x squared. Then, and this is very important, and I'm not sure I'm seeing everybody doing it right now, we have to subtract this. Okay? Because we're trying to find out what it takes to build up this polynomial here. And we know if we've got an x squared here, then when we multiply this by this, we've got this much. So we're going to subtract this. Meaning we're going to subtract the x cubed, we're going to have to add the x squared, because we subtract a negative x squared, we add it. Anyhow, that's the process. And now we get 3x squared minus 4x. Well, then we divide x into 3x squared. Now, if you didn't remember that this is supposed to be subtracted from this, you'd have put an x squared down here. Okay. But remember that this always has to be subtracted. That's why I put these little reminders in red. Okay. Then x goes into 3x squared. How many times? Well, you can ask yourself, what would I have to multiply by x to get 3x squared? Well, I have to multiply 3x by x to get 3x squared. So we have squared, and then the 3x times the -1 is negative 3x. Then we make ourselves a note. We're going to have to subtract this from this. We're going to have to subtract this from this, which means we're going to be adding the 3x to the negative 4x, and we get minus x plus 1. Okay. Now, I explained it when we did it in class last time, but I brought the 4x down here because it's just kind of clumsy having to look all the way up here to see what we're going to subtract the negative 3x from. Put the 4x here so we can see immediately what to subtract the negative 3x from. Anyhow, now what would we multiply by x to get negative x? Well, we'd multiply x by -1. And we get negative x. And -1 times -1 is plus 1. Well, this matches this. So when we subtract this from this, we're done. There's no remainder. So that's a process. You do problems and you get used to it. Okay. It's not difficult to do. Now, here's the point, because this goes back to questions that was asked earlier. What about that I thing? Well, we might get an I out of this. Okay, this tells us that our polynomial P of x, which is x cubed plus 2x squared minus 4x plus 1, equals x minus 1 times x cubed plus 2x squared minus 4x plus 1. Okay. When you divide something into something else, you get the quotient. That means that this times the quotient equals this. except I wasn't paying attention to what I wrote down. What I should have written down here is the quotient x squared x minus 1. Okay, so now what are the zeros of P of x? Well, let's write it down. X minus 1 is x squared plus 3x minus 1 equals 0. That means x minus 1 equals 0, or x squared plus 3x minus 1 equals 0. Okay, now x minus 1 equals 0. We solve quickly, and we find that x equals 1. X squared x squared plus 3x minus 1 equals 0. And what's that going to give us? Well, how do you solve this equation? That's a quadratic equation. Quadratic formula, which is going to be negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, well, b is negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 1, putting it in order, all divided by 2 times 1, which is negative 3 plus or minus the square root of 13 over 2, which is negative 3/2 plus or minus the square root of 13 over 2, which is approximately equal to negative 1.5 plus or minus 3.6 over 2. So x is this plus 3.6 over 2, which is, got that wrong, that was like 2.1, it's like 1.05. For x equals negative 5 minus 3.6 over 2, which is negative 8.6 over 2, about negative 3. Now, these are approximations. Is that 3.6 is exact? The square root of 13 is between 3.6 and 3.7. I can't tell you off the top of my head exactly what, and I could figure it out a little more closely, but your calculator will give you the results. Okay, so what have we done? We started with this polynomial. By trial and error, we figured out that 1 was a root, so we divided it by x minus 1. Here's the process, and we got x squared plus 3x minus 1. So that the polynomial is x minus 1 times x squared minus 3x minus 1. This times this equals this. Now, what do we know about the graph? Well, we know that at x equals negative 4.3, close to it, we have a zero. We have a zero at x equals 1, and then another zero at x equals 1.05. So those zeros are really close together. Then we can do the long run behavior and everything, okay? And we can find the y-intercept, which is easy, that's 1. Now, when we do the long division, there's no way to easily predict what this quotient is going to be. But the quotient, if we divide a linear term into a cube, is always going to give us a quadratic. Okay? So good, start with some p of x. Equal to x minus 1 times x squared plus 3x plus 6. One more thing I should say here. If the zeros are 1 and 1.05 and negative 4.3, we can take this information and we can say p of x is approximately equal to x minus 1 times x minus 1.05 x plus 4.3. Okay, we just do x minus this zero and x minus this one and x minus negative 4.3, which gives us x plus 4.3. Okay, now if we have this, so this equal to 0 splits into this equals 0 or this equals 0. So solve it. I'll solve this one for you. This is x equals 1. Now use a quadratic formula to solve x squared plus 3x plus 6 equals 0. Is it good?
Rats.
I'm not sure that's focused as well as it could be. Okay, there it is. Okay. Okay, very easy to work it through. A is 1, B is 3, C is 6. We plug into the quadratic formula. All I have to do is the arithmetic here. That's 9 minus 24, which is negative 15. And then I write it like this. And then, step that not everybody is getting just yet, but the important step, it answers a question somebody asked me at the beginning of class. Square root of negative 15 is not a real number. There's no number that you can square and get negative 15. And if you plug square root of negative 15 into your calculator, it's either going to tell you square root of 15 times I, or, 3.8 something times I. Or it's going to tell you it does not exist, or error, or it's going to blow up. I don't know, something's going to happen. Okay, depends on your calculator. All right. Now, why do I write it like this? Let's just be sure we understand this. Well, negative 15 is equal to 15 times negative 1. The square root of negative 1 has I. And that's where I comes from. Now we can see if this polynomial has two zeros here, that they're complex. And everybody in here did at least part of the assignment, I think, on complex numbers, where you were adding them and subtracting them and stuff like that. Okay, so you're used to the I. Some people stopped at the point where they had to understand what I meant. Okay, and it's just the square root of negative 1, and this is where it comes from. In this course, that's the only place you're going to see where an I comes from, unless it's just given to you. Okay, so the zeros are here. Okay, the only x-intercept is at 1, 0, because these other two numbers are not real numbers, so you can't plot them as numbers on a graph of x versus, or y versus x. Okay. So in the problems you see, numerous problems in the assignment first require that you figure out what value of x, what real value of x gives you 0. You do that by plugging in numbers like 1, 2, 3, or negative 1, negative 2, negative 3. I don't think any of the problems require the rational roots theorem, which gets more complicated than we really need to get at this point. Okay. Something you don't use unless you study some pretty advanced mathematics. And figure it out then. Now I'm going to go over it because I want to give people who are doing extremely well in the course a chance to show off. But for anybody that's making a B or less, it's not going to make any difference in their grade. Wouldn't even hurt somebody making a low to medium A, but I want to give people a chance to do that. It's almost it's an optional problem if I include anything. So it wouldn't even hurt somebody that's making an A. But as an optional problem, it can help out a little bit and give somebody some satisfaction and a background that they can use because they might be going into some heavier math beyond calculus. Okay. Well, that's kind of it. And that's what complex zeros are. Okay. So it's fairly straightforward if you just know that when you get a square root of a negative here, that means the square root of that number times the square root of -1, which is the square root times r. Okay. And then it doesn't affect your graph. It actually does, but in a subtle way that we don't touch in pre-calculus. Okay.